This is the first of a couple videos on variation, which is another application of rational equation. So let's look at the top of the notes where I define direct variation versus inverse variation. Direct variation uses this equation, y equals kx, or it can be y equals kx to some power. But notice that k is multiplied times x. And what does k stand for? K stands for a constant. And yes, we do know how to spell constant in math, and I know it doesn't start with a k, but we still use k to stand for a constant. Here's an example, a very simplistic example. The more I eat, so that's increasing, the more I weigh, that's increasing. So one of them going up is causing the other one also to increase. There is a direct relationship between the direction the first one is going and the direction that the resultant second one is going. So let's try one of those and then we'll talk about inverse variation. It says if y varies directly as x and y equals 6 when x equals 3, find y when x equals 7. Here is how you set up all variation problems, and this is very important. Step 1. The first thing you do is, because it says directly, we're going to write this equation, and it didn't say anything about squaring or any power. So y equals kx. So you write your variation equation. Second, the problem is going to give you the initial values. And it does. It says initially y equals 6 and x equals 3. So we're going to fill those in. 6 equals k times 3. Step 3 is we're going to solve for k. So I'm going to divide both sides by 3 and I get k equals 2. Now that's not my answer, but it's the first piece that I need to have in order to find my answer. Now what you need to do is you bring this up, you bring your original equation over, and you write it again. Y equals, but this time you take out the k and you replace it with whatever it was you found k to be equal to. So 2x. That's that next step. Now we put the last part of the problem in where it says find y when x is 7. So y is equal to 2, take out the x, put in the 7. Y is equal to 14. So that is my final answer using the process of write the variation equation first, put in your initial values, solve for k. Bring up that k, bring your equation over, write it again, but replace the k with the number you found, put in the next values, and solve. And we're going to use that same process in every single one of these. So example 2. Hooke's law for an elastic spring states that the distance a spring stretches is directly proportional, so that is direct variation, that's another way to say directly varies, to the force applied. So I know that what I have, before I read the rest of the problem, is d for the distance that it stretches and f for the force that is applied. Instead of x's and y's, I have force and distance here. So I'd like to write our direct variation equation before we ever even finish reading the problem. So it says the distance is directly proportional. So the distance is k, notice there's always a k, directly proportional to the force. So there is my initial equation. Then it gives me my first values. If a force of 150 newtons stretches a certain spring 8 centimeters, so my second step is to put in my initial values. The d, the distance, is 8. K is k. The force is 150. We are going to solve for k by dividing both sides by 150. I'm actually going to leave this k as a fraction just by dividing both of these by 2 rather than turning it into a decimal. So I end up, I didn't finish writing that, with 75. So I have 4 over 75. I just simplified that fraction. Bring it up, bring the equation over, write it again, but use the k that we just found. So that's step 4. Step 5 is put in the last values. How much will a force of 400 newtons stretch the spring? So it's giving me this force of 400. So D equals 4 over 75 times 400 over 1. I can simplify by dividing by a GCF here. So I'm going to divide by 25. 25 goes into 75 3 times. It goes into 416 times. So I end up with D equals 4 times 16 is 64 over 3. And now if we actually do that division, we end up with 21 1/3 as a fraction, or 21.3 centimeters. The key here, though, is following that exact process that I did in this first one. Follow the same process down here. Now, let's compare that to inverse variation, because we're going to do some inverse variation problems in just a minute on the next page. So let's look at inverse variation. Inverse variation says y equals k divided by x. And again, the x can be to a power. So rather than it being multiplication, which is direct variation, this is division. They both still start with y equals k. Y equals k. This one is multiplied times x. This one is divided by x. Here's an example. The more I exercise, so this one is going up, the less I weigh. It going up causes this one to go down. So they are related in an inverse manner. One goes up, the other goes down. Let's look at another problem and we'll see whether it's direct or indirect variation. Example 3 says the distance a body falls from rest varies directly. So going back to our other page, we're going to be using direct, kx, but this time it says as the square of the time. So it's going to be squared. So let's look at the two things we're comparing. Again, I have distance, because it says the distance a body falls, and then it varies directly as the square of the time. So t equals time. So let's write our initial variation equation. So instead of y, it's distance varies directly, so d equals k, as time squared. You really have to translate those words from the problem. Now we're ready to put in our initial values. It says if a skydiver falls 64 feet, so that would be distance, in 2 seconds, don't forget we have to square it. We'll finish reading in a minute. We are now going to solve for k. So 64 equals 2 squared is 4k. Divide by 4, and I get k equals 16. I didn't mean to put another step there. That's still part of step 3. I bring this up. I bring my equation over, and I write it again. Same thing, but take out the k, put in the 16. Now we can finish reading. How far will she fall in 8 seconds? Well, this is a time, so that's going to go in here. So step 5 is to put in what we're given times 8 squared, or d equals 16 times 64. Put that into your calculator, and what you get is the distance that she will fall is 1,024 feet in 0.8 seconds. I hope you are noticing, though, that every single time I'm working these problems the same way. I work down, bring it up, bring it over, work down again. All right, let's look at the next one and see if it is direct or inverse. And you may have heard me say indirect. Indirect and inverse mean the same thing. So example 4, in the manufacture of a certain medical syringe, the cost of producing the syringe varies inversely as the number produced. So let's see what we're talking about. Cost and number. So let C equal the cost and N equal the number. We are stating our variable. And I'm going to go ahead before I read any further, and I'm going to write my initial variation equation. It says the cost varies inversely. So there's my K, but I divide by the number produced. Now I'm ready to put in the initial values. So if 10,000 syringes are produced, so that's the number, so I'm going to put 10,000 here. The cost is $2 per syringe. So I filled in the pieces I was given. I am now going to solve for K by multiplying both sides by 10,000, and I get K equals 20,000. That's the first thing that I need. We bring it up, we bring this over, and we write it again. But we put in 20,000 for our K. That's step 4. Step 5 is put in whatever value they give you next. Find the cost, so we're missing the cost of producing 25,000 syringes. So the cost is 20,000 over in 25,000. I can quickly divide by 1,000 there and cross those off. So I have the cost is 20 over 25. Now, how am I going to write that as money? Well, if I can change that over 100, which I can by multiplying by 4, I know it's 80 out of 100, which is 80 cents. Now think about it. It makes sense. If you're going to produce more, you're going to produce 25,000 instead of 10,000. Then that lowers the cost per one. Used to be $2 for 10,000, and now it's 80 cents per 25,000 per one out of 25,000. By the way, if you didn't follow that, how to change that to money, just divide 20 divided by 25, and you're going to get 0.8, which is the same thing as 80 cents.